So for today, this is linear inequalities. All right, they are very easy in my opinion. They're basically just a little graph. I'll show you one where you graph this and I say here's where x is 5 and I graph a line like this and then I just have to tell whether it's dotted or solid line and then which way to shade. This is how they kind of look when it's all done. That's really all there is to it. Now I'm going to show you the fine print in a moment, but that's about graphing inequalities. All right, so back to the beginning here. Oops, that's not the beginning thing. So you need to know these signs, and a startling number of kids can't tell the difference between less than and greater than. I mean, they know one's different than the other, but they don't know which of these is less than. I have a way to know. It kind of looks like an L. Do you get how that one kind of looks like an L? Does this one look like an L? Not unless you've got issues with things being backwards or forwards, which I would understand, then it might look like an L to you. But if you know which one of those two looks like an L, that's the less than one. Okay, so this one is said as less than. A lot of people think that it depends what numbers are on the sides of it. It does not. That is pronounced less than, period. Even if you say it like this and people want to say, well, that's x is bigger than 8. That's not how you say it. How would you say this one? 8 is less than x. Now, would it also be true if you rewrote it that x is greater than 8? Yeah, but you can't pronounce this sign as a greater than. That's a less than sign, period. Okay, but do you get how you could rewrite it this way? A lot of people like it better that way because we read from left to right and we want the variable to be on the left. It feels better that way. And I'll bet none of you finish your problems like this. 12 equals m. You want it to be m equals 12. It just feels better that way. So if you want to rewrite them, you may, but you got to reverse the signs. So if I said 2 plus x is greater than or equal to 11, I would keep the x on the left side. Solve this. X is greater than or equal to 11, 10, 9. There we go. And then the new thing for today basically is just reminding you, I know you did this before. This is a review day. Reminding you how to graph that and figure out which side to shade on. All right. So let's move on. Find this slide. What do these mean? Let's just cut this down to make it faster instead of having you write these all in there. That's which one? Less than or greater than? Less than this one? This one less than? And this one? Good. And you're throwing an or in there. You know, the details are sometimes important. Less than or equal to. Which one is it? Is it less than or equal to? Less than and equal to? Let's go with ages. Let's say it's 16. Can you be less than and equal to 16? No, that's impossible. So it's or. You're right. It's or. Okay, less than or equal to. You can be less than or equal to 16. All right. There might be a 17-year-old in here. That's possible. Okay, so anyway, just remember how to say those properly. This one, if you were going to do an inequality, it would just be you pick a letter, and since this is about height, you might be H. You could pick Q. You could pick X. Doesn't matter. Taller than. There's no taller than sign, but come on. It's pretty much what? Greater than. Greater than 48. I would argue that most amusement parks wouldn't use that. What do you think they would use that would be very similar, but different? Do you really think they measure the kid and he's 48, they're going to say, nope, you're 48, you can't go on the ride? Because that's what that means. All right. Or in this case, greater than. They want the taller kids. Greater than or equal to 48. Because if the kid hits 48, they're not going to say, oh, you're 48, you can't go. The kid will be like, it says 48, I'm 48. So anyway, they would always use greater than or equal to for that kind of thing. All right, and this would be great if they actually put this on the sign. It would make people know math, but they're not going to do that. They're going to say, you must be taller than or equal to 48 to ride. All right, this one's too easy, just insultingly easy. Let's go to 3. This one's definitely got more of a twist. I'll give you a hint. It's something like this. 6x minus 3y is equal to 50, except that's not the right answer. But it's an equation kind of like that. Try to figure it out. I'm going to pause for a second while you do that. Okay, so we have this answer. 3y plus 4x is less than or equal to 100. Now, some of you are probably saying, but I chose different variables. I chose q and r. Fine. Or maybe I reversed my x and y. It's fine. But really what needs to happen is you need to define your variable if you're going to do something like this. So if you said that the prepackaged items were Y, then that's what she did. Okay, and so Y equals prepackaged items, and X equals fresh. If you use that, then your equation would be this. And I get some of you have those reversed because you came to this first and you thought, oh, I'll make this X and I'll make this Y. And so then this is X and this is Y and this is X and this is Y. It's fine, but you need to define them because you can't just assume your reader will know what X is because there's two different things it could be. All right, moving on. T is less than 20. I've got one that's like that. T is less than or equal to 20. And I want you to do, what would that statement be in the context of the top 20? That top 20 test that I'm going to give you later. What do you think T is less than or equal to 20 would be as a written statement? I'm going to pause for a second. What written statement would go with the top 20 and T is less than or equal to 20? So hopefully you said that the time would need to be less than or equal to 20 minutes. Yeah, you need to finish in 20 minutes. And it can be less than that, or it can be equal to that, but then you need to be finished by then. So we had a little interruption there. We're back. This one, if you're going to write a statement for it, the key here is that these are usually like, that's how much money it is, and that's how much tickets there was at that price. Or cans of beans cost $5, and this is the price, and this is how many there are. Okay? And usually we don't say greater than or equal to on these. Because why? Because usually if it's money, you want to stay under a certain price. Because people aren't saying, make sure you spend more than $50 at the grocery store, because I'll be mad if you spend less than $50. You know what I mean? Like, they always want to keep it down. So usually it's a less than number. Only scenario I can think of where it'd be a greater than would be, you've got $55 to spend, and if you don't use it, you lose it. There are gift cards that are like that. Like, here's a gift card, and if you don't spend it all, well, just the rest goes back to the company. So you're like, well, spend at least $55 because that's what our gift card has on it. That's the only scenario I can think of where you might say greater than or equal to. All right, moving on. Now, these, I didn't find this to be that valuable, so I'm not going to do it with your hour, save us a little bit of time. But basically, if you were going to write this as a statement, do you get how you might want to actually break it into two statements? Would you break this into two separate X equals things? X is this and X is that. I'm going to pause for a minute while you break that into two separate statements. I noticed some people had both the X's on the left, and some people had one on the left and one on the right. If you haven't already, would you please move your statements so that the X is on the left in both cases? I mean, I get that this one naturally would be 25 is less than or equal to X, but I'm asking you to rearrange it so the X is on the left. And you need to know how to do that, so practice that. I'll pause while you try that. Okay, so here's what I'm hoping. I'm hoping you have X is less than or equal to 40. That one was the one that was simple because the X was on the left in the first place. And the other one, you'd say X is greater than or equal to 25. Notice when I switch the spots, I have to switch the sign to the other way. Raise your hand if you had those two statements. Okay, good. Then let's move on. How do we graph these things? Well, I showed you how to graph that one, but I was really quick about it, and I wanted to show you a little bit more. It's technically wrong. Can anybody tell me what part of this should be a little different? I'm really close, but yes, sir. Yeah, like this. Okay, good. Yes, that is. Sometimes I've heard it called a dotted line. Sometimes I've heard it called a dashed line, but you are right. Why should it be a dotted line? Sometimes, and other times it is solid. Because it's not equal to. If this had been a or equal to like this, then we wanted a solid line. This one is a less than sign. And what does that say about the line itself? The line itself is at 5. So if you want things that are less than 5, don't include the line. So you make it a dotted line. This one, put the line at -3. Everybody put in where you think this should be. Be careful, it's different because it's a y versus an x. Put in the line where you think it should be. Make it solid or dotted based on the right sign. And then shade in the right direction. Did you put it at y is -3, which is down here? Did you make it dotted? You shouldn't have. You should make it solid. Why? Because the sign says or equal to. And that means the line itself works. That means you make it a solid line. And then the last thing is where to shade. Well, it says y is bigger than -3. Where are the things that are bigger? Above or below? Above. And so you shade above. All right, this is the only kind where you shade left or right, because it's the only kind of line that goes straight up and down. All the other lines are at an angle, so you shouldn't think of them as left and right. You should think of them as above or below. All right, so let's look at this one. Graph that line, decide whether it's solid or dotted, and then shade in the right direction. And if you've got this, you're pretty much done. Pause for a second while you try that. I hope you started at -3 and then did the slope from there, right? Slope is 2, so I'm going to rise 2, run 1, rise 2, run 1. Should it be dotted or solid? Dotted. And last but not least, should I shade above or below it? It's intuitive. If you solved it for y, it is what you would think. That feels like less than, feels like below, and it's right. You can trust it. Thankfully, this is intuitive. It's below that line. All right, now, there are some cases where your life depends on your answer. Okay? I know in math class it doesn't. But in the real world, there are people who are making decisions that are going to affect people's lives. You screw up the safety mechanism in a car, you can get people killed. Okay? You're not careful with your equation. Sometimes it just costs the company billions of dollars. It did when they screwed up a flight to Mars. They had a Mars satellite that was supposed to orbit Mars and take all these awesome pictures. It got there, it went down to go into orbit, and somebody had screwed up one calculation and it crashed. They figured out what it was. It was a conversion between meters and feet. They had done it in feet where they should have done it in meters, and that's all it took. And $1 billion and like 100 people's time for years, all for nothing because of one calculation. So my point is sometimes it matters a lot if you're right. How could you check yourself? There's a way to check. Yes? XY charts are awesome, absolutely. Let's pick a spot. I picked 0, 0. How could I use 0, 0 to test whether I shaded the right way? Yes? And for the y. You just put them both in. That's a point, 0, 0. I know you're thinking test 0, see what y comes out to. Don't do that. Just stick in 0, 0 and watch what happens. 0 is less than -3. Does that feel right to you? No. And so we shouldn't be shading there. See what I mean? This doesn't work, so that's a good thing. We weren't shading there. It's actually probably going to make more sense to you if we take a spot that is in the shaded region and make sure it does work. So let's say here's a spot at 4, 0, 4, 0. I'd like you to put in the 4 and the 0 and make sure that it works. Make sure it actually works in the equation. All right, so I'm going to drop in my x is 4 and my y is 0. And is this really true? Is 0 less than 8 minus 3 is 5? Is 0 less than 5? Yeah, so it works. So I should be shading over there. So if you're just trying to figure out if you're shading on the right side of it, the correct side of it, I should say, and take a spot that you think should be shaded and make sure it actually works. All right, last thing I want to bring up is all the ones we've done so far were always solved for y. Do you get how solving for y is smart? because it gives you y equals mx plus b form. You know the y-intercept right away. There's all kinds of good things that come from this. Can it be done without solving for y? Yes, but it's just slow and it takes an xy chart and all kinds of stuff. Then you have to do that test with a point thing because you can't just say it's less than, shade underneath it. Not true. Not unless it's solved for y. So always solve it for y. And the last thing is, I wish we had an example of this in our Smart Notebook, but we don't. What if this was a minus right here? Why would you flip the sign? Because you're solving it for y. Let's try solving it for y. Everybody change that to a minus to y. Just change it to a minus sign right there. And then what's my first step in solving it? Subtract 3x. Everybody do that. And I have negative 2y is less than negative 3x plus 10. Yes, you could reverse those two, but I know in the long run, I want my x part first, because then it's in slope-intercept form. Now is the key moment. What forces the sign to change? So far, it has not changed. What will now force the sign to change? Yes? Dividing by a negative. Divide negative 2, divide negative 2, divide negative 2. And I will have y is greater than, sign changed, 3 over 2x minus 5. Okay, I know I changed the original problem on you to include a negative to show you that the sign has to change. Be careful on that. By the way, also multiplying by a negative. As long as you do it to both sides, it changes the sign. Multiplying or dividing by a negative is what changes the sign. Here, this is important because kids sometimes hear this part. There's a negative, change the sign. That's not what I said. There's a negative in this problem. That doesn't mean I'm going to change the sign. Get what I'm saying? It's only if I have to multiply or divide by a negative. What's my first step here? Adding 7. Does that make me change my sign? No. If I had multiplied or divided by a negative, that would make me change my sign. Dividing by 3, does that make me change my sign? No, it's not dividing by a negative. So I never changed my sign, even though there was a negative in the problem. So don't think that just because there's a negative, you should switch the sign. It's if you multiply or divide by a negative. All right, you've learned everything that you need to know. Your worksheet now, open it up because I'm going to tell you which ones to skip. For those of you that are new to this class, new to me, you might just think you do all of them, but I actually cut it down. Here's ones that I feel like the first couple here are important. And then you get to number 3, and it's the first one where you got to solve, and it involves dividing by a negative, so you need to know that. Number 4 is the only kind you have to solve with 2 steps, so I have to have you do 1, 2, 3, and 4. But these two are very similar to each other, and you don't need both of them, so you can skip number 6. Next, you can skip number 7. And you can skip number 10. You also have to be wise with this. If you realize that you do number 8 and then you were terrible at it because you check it and it's all wrong, you might be smart to practice another one. I'm not saying you can't do number 10. I'm just saying you don't have to. And last is skip number 12. So these are, do them if you want to, but I'm not going to be grading those tomorrow. Okay? All right, get your homework done for tomorrow, because this will be the first one that isn't a Schoology quiz, and you'll get to see how we grade them in class. All right, that's all I got for you for today.